Okay, folks, this is now being recorded, so please understand that anything you say in the room will go into the recording. You've all seen the note well at this point. We are working on the back end of the Hangouts. It sounds like some of our remote participants are having a little bit of trouble getting in, so there may be a bit of a scrum going on there. In the meantime, we're going to go through a little bit of administrivia right now. Thank you for volunteering to take minutes for us. And then we will go on into the RTP Plus media. The biggest piece of the administrivia is going to be tomorrow's agenda. Just a second. Okay, so for tomorrow's agenda, we previously had basically the full day for data channel, and the data channel folks say, we don't need the full day. And that's sort of handy, because as it turns out, we're going to need various people to go through the discusses that we got from the ISG on the RTP use case draft. So we haven't figured out the use cases and requirements draft. So there were a flock of discusses on that which need resolution. And we will need to go through those as part of tomorrow. At this point, I guess I'm looking for guidance from the room about how much time we think it'll take to get through that. You think maybe an hour? Okay, so do people want to do the use case discuss resolution at the beginning or the ending of tomorrow's meeting? Okay, so we'll do it at the beginning of tomorrow's meeting, and I'll update the agenda accordingly. Any other bashing that we need to do of today's agenda before we switch to the presentation? Okay, hearing none, I'll ask the next speakers to come up and mic themselves.
Yeah, definitely on. Let's see, where should I? Oh. Somebody out in audio land should mute. Yeah, so even I see my slides. It's good. So I'm Magnus Westlund. I'm here to talk about or discuss our RTP usage draft and the working class call comments. So my co-author is Colin Perkins, and I don't know if Colin is online. He should be remotely. Good. And Jorgot. So next slide. Yeah. So I want to thank all the ones who actually provided review comments. Ulle, Jim, Bernard, Suash, Alex, Colin, Roni, and Ben. Thank you all. Next slide. So we did submit a new version, but talk a bit about what changes into that first, and then we have a number of issues. We'll allow some time for more discussion on those, see what we should do with them, and if there's anything. And then I also have one slide about clarification on the TR-int for interoperability with SAVP or AVP. So let's dig into this. Next slide. Yeah. So, so one of these changes that gone into the new version was trying to clean up this SDP reference, saying not mandating SDP unless you actually have SDP for signaling. Well, some follow-up the last day on this, but if you have opinions on that, please you can provide it on the mailing list also. So section 4.1 is probably where most changes happens so far in the dash 14. We did replace a bit of RC 2119 language, which already existed, and instead referenced the places where that was defined. That doesn't mean that all are removed, because there's some which actually only exist in that section. We also put in this reference that people asked about for different mechanisms, where they were defined and what the text about them are. So, reduced minimum, we also put in a change there from actually recommending to implement this to requiring it. And we also clarified that, yes, when you're doing timeout, you actually have to use not a reduced minimum interval. So this reduced minimum interval is that you take the session bandwidth in kilobytes per second and take 360 divided by that. Then you get the minimal interval that's allowed between RTCP for basics. And instead of having that in the regular 5 seconds, you use this value. But when you're calculating timeouts, you use the 5 seconds instead. So that's the change. Next. Yeah. Yes. Now it's on. Wait for it. Try it again.
Okay, try now. All right, so Magnus, you said you're using session bandwidth.
Yeah.
Where does that come from again?
Can come from, I mean, if various sources, I would say, depending on where you actually configure it. It's to some degree in either it's if this is STP, we do have AES, B equals AES.
Correct.
Yes.
And you know who produces that, don't you? An attacker.
Okay.
I'll let you think about that, but
yeah, I don't think that's.
I don't know what the right answer is here either.
But
follow the mic, by the way. I can't hear you, and I'm in the room.
This is. I was getting a whole lot of fallback.
Yeah.
Is that good? Yeah. Can you hear me? Okay, good.
So actually, it is a serious issue to some degree, because we need RTP, RTCP bandwidth to be configured. This and session bandwidth, the RTP, RTCP bandwidth is also possible to modify in those cases. So that's TAC is in general applicable. So I have to think about that, but. And I will hand out another.
So, like that. So I mean, Martin, walk me through your attack scenario here. Your attack scenario is that I'm on AppRTC and I'm calling Justin, but AppRTC makes me send him like 10 times as much video, even though he accepted the call. as ordinarily? What is your model?
It's that it's not congestion controlled RTCP.
So
That's
you're
the
going to
issue.
you are going to get some level of bandwidth that you're going to be sending towards Justin, and it's going to be congestion controlled, and it's going to follow all of the rules that we're following. But if the RTCP reporting interval is calculated based on something else, you're going to get more or less RTCP than you may or may not want/need. I don't know. I think that's all it is. It's not.
Right. I was expecting RTCP is a 5% fraction, of RTP, and RTP is congestion controlled, and B equals represents like the maximum that the congestion control should ramp up to. So it seems like RTCP ought to be expressed in some sort of fraction of the RTP traffic as opposed to like some absolute value, which would then like send that from the very beginning of the call.
Okay. Yeah. There's some issues with that also, but I think we have to at least have that type of safeguard with regards to how RTCP it's.
Yeah, you might want to use what's actually permitted as or something like that. I don't know how the browsers are going to calculate this one, but
well, I mean,
because what's in use may be some smaller fraction of the actual bandwidth for the session.
I guess the question was, how should a browser interpret like a specific RTCP bandwidth value? Is it just a maximum for how much RTCP it should ever be sending? And if so, is that actually useful?
Yeah, so I always imagined that B equal AS was another way that you could provide a limit on the amount of bandwidth that was being allocated a session, and that's all it was.
Right.
Yeah.
But that doesn't address the RTCP part.
No. I think we have to do. Let's think about that and see what we can propose.
So we need, Ted Hardy speaking, and I'm going to remind people to please say their names before talking because we are recording this and because there are remote participants. Speaking of remote participants, Colin, if you could unmute yourself briefly and then remute yourself, the folks recording this would appreciate it.
Hi.
We don't have a whole lot of time.
No.
When are we going to get the people together who need to think about what to propose text around? First break, lunch? I hate to pressure you, but
I will try to do something, but
you go on parental leave really soon now.
Yeah.
So.
Well, so yes.
All other considerations aside, you don't want to be having a crying baby and come up with this text. So.
We'll do a good job of coming up with text. No, let's see what we can do before this meeting ends. So, preferably today. Next slide. Yes. So this is one more thing which clarifies the requirements to ignore unknown RTP and RTCP extensions. So this is the proposed improved text. So. I don't know. Yeah. I will look. I think it's most likely the slide doesn't look like they do on my computer, so it might be the viewer here. Yeah.
This is not working. So, Colin Jennings, I mean, isn't this pretty much just what RTP says? I mean, I don't have any problems with putting this text in, but this just seems like a fact of life, not really something worth a whole lot of discussion.
No. I just go ahead.
Just do it. Yeah.
Just people.
Fill the draft with apple pie. Let's go.
Yeah. Next slide. So. In section 4.3. Yes, this is the next of Colin's asking about if you actually signal that or that you support a particular payload format, you better actually be able to receive it. You must, not should. That's a very good catch. And then when it comes to both section 4.5 and 4.6, we did this clarification where 4.5 is RTP, RTCP max. It's required to implement. You only use it when it's you negotiate that you're going to use it. The same is true for reduced size RTCP. So, next slide. So now we're up to 5.2.2. This is header extension. In this case, the client to mixer audio levels. So use of encryption is recommended, that you actually turn it on, and just knows that yes, you may be able to disable this through signaling or API. And then we have in 7.1 about bandwidth signaling.
So Cullen, again, just on the previous one.
Yeah.
I mean, I think that this is actually one of the ones where the application, like in RTP, for this to work, the application needs to be able to decide what it needs to do. Because different applications, it's not like the application knows that these headers need to be encrypted or not encrypted. It won't work if they turn up differently than what the application's expecting for lots of applications. So I'm fine with, of course, the default if you don't say anything is encrypted. But I think that in this draft, we need to say that we need to provide an API.
Yeah, but I mean, this is all I can do. I said, I just signaling or API, go define the API for it. It's fine. We already, I mean, the hook is here to do exactly what you want. It says.
Okay, but in other places we've put, there should be an API to control feature X. Right.
Yeah, we might not be super consistent about that, but yes, I mean, we
okay,
can, if you want that wording, I mean.
As long as we're going down the path that people think that we're going to have an API to control this from the JavaScript level, I'm fine with it. I just want to make sure that we're all on the same page on that. Right? I understand it's an afternoon topic, not a morning topic, but is that? Okay.
API or signaling. It's
signaling too. Right?
Yeah.
Can't you just do this through a munging SDP if you had to?
Yes.
There's your API, worst case.
I'll accept that, but no, I don't. I'm not sure you can do that through munging SDP.
Yes.
Okay, if I see, because you're saying it has to be supported in signaling here, therefore, okay.
Yeah. Well, I mean, the header extension's encryption is signaled by putting an attribute on the type code for the header extension, which indicates it's encrypted.
Well, you have to offer both the encrypted and unencrypted versions in the SDP.
Yeah.
And then you accept which one you want.
Yeah.
So, Martin Thompson, if you consider SDP to be sufficient in this one, you also have to stipulate that the local description can be modified in order to produce this. It's not sufficient to say that we require it be in signaling, because that really only applies to the remote descriptions. That's all.
Yeah.
Why?
Well, so it's not hard to offer both. There are two different type codes in the.
This sounds like it needs like a more focused discussion, perhaps in the afternoon session or the W3C session.
Yeah. So, okay, I'm moving on. Next slide. Yes, section 7.2, which was about this, mostly an example about how RTCP bandwidth relates to congestion control. I mean, the text actually there were more lacking guidance to actually implementing congestion control, designers, etc., which would be the ARMCAT working group type of people. So we actually removed it. Colin is gonna put it into his individual draft about RTP congestion control feedback into ARMCAT to ARMCAT working group. So next slide. So now we're into the open issues. I hope this one first is going to be easy. So this is about the MultiStream Optimization draft. Our draft says recommended. Colin noted that he maybe prefer May. I want to give a little bit motivation why we put it on recommended. So the stream optimization needs to be signaled, which actually is not in the draft, which should be clarified. But the main goal here is actually how much gain there are to get from this multi-SSRC optimization. The table below here on the bottom of the slide shows, here is the number of SSRCs that each endpoint, this is figures for 2 endpoints with the same amount of sources, SSRCs. And then you can see here what the number of sources I simulated for. Aggregation is just the scheduling of multiple SSRCs reports in the same packets, which is in the MultiStream draft. Report groups is the optimization. And then it's both at the same, at the third row. So for one, this actually costs you a little bit. Not much, but a little. And then you start getting the gain. So you see the report groups is the big gain. And when you're up to 4, which would represent basically audio video with FCC or retransmission, you're actually getting a gain of 15% lower average RTCP report intervals, thanks to this optimization. So that's the motivation why I think it's recommended. So input on this.
Just go a little bit farther and say why a 20% reduction in the rewarding time, like how that makes my life better.
So,
I'm trying to help you advertise it here.
Yes. So this improves your possibility to send feedback, of different type. For example, actually sending like NACs or sending FIR or things like that, because this reduction in time also means that you're resetting these early transmission timers, etc., to actually be able to send RTCP feedback earlier, quicker, and in general you will get more detailed reports. So, and the big thing which isn't seen here, but actually is why this looks like it does, is that more SSRCs basically doesn't result in longer reporting intervals. What you configure based on bandwidth for one source grows very slowly with number of sources, while if you have standard AVPF, it grows quadratically a reduction. It's the square of number of sources that you get reduction from, because you get both bigger packets and more sources to report on. So you go from go back to linear increase with number of sources.
So I don't have any strong opinion on this. If the working group's happy with recommended, it's very good with me.
Bernard, you? Oh, you get.
Okay, I got it. I basically support Cullen because I think this is a good thing, but it hasn't been implemented widely yet. So do we really want to make it recommended at the moment? I'd say people should go look at it, and if it turns out to be a good thing, do it. But it seems to have a new draft, make it recommended right away, seems a little bit much.
I think that's where I'm at too.
Okay, fine. Let's say it's made. You record that. You go May. Next slide. Next issue. So RTP retransmission. I included text here because it's what's the draft currently says in section 6.1 is that receivers are required to implement support for RTP retransmissions, and its senders may retransmit packets, or have the capabilities to retransmit packets. And this is negotiated in the session if you're going to use it or not. That's the current requirements level. And this has basically been there for a long, long time, since the Stockholm Interim and on mailing list discussion afterwards. The authors proposed no change, but I definitely want to hear feedback, and especially from Cullen, I think will raise this issue and wanted to change it. So.
Again, I don't feel strongly about this. This is fine. This is much more widely used than things. I sent on the list that I thought this was useless. Magnus and I had a discussion about this. Multiple people said it's not useless, and they're right. Particularly if you're willing to allow your video to lag behind your audio, then I can see how this is deployed. So, take back what I said on the list.
Okay.
I'm happy with this.
Good. So text stays as it is. Next issue.
So my only question on this is, why don't we have the same sort of recommendation for FAR/PLI? FAR and PLI are currently optional compared to being required, and it'd be nice to have a uniform.
No, they're not. I think you have to look at the draft. So.
I'll follow up separately.
Next slide while they look. Yeah. I mean, we're going to get back on PLI, and I think we can take the FIR. There is a slide later in the deck about PLI. So we can take that then. It's optional? I thought it was.
Yeah. 511 and 512, PLI and FIR are optional. Oh, they must understand PLI. Oh, they must, sorry. PEBCAC.
Yeah. Yeah, so it's optional to send the feedback messages. It's required to be able to respond to them and deal with them. Okay, forward error correction. The draft currently says there are FSC block-based schemes that you can use with RTP. But there's no consensus on what to use. That's what it says. This has been the state of the draft. It's been raised. I mean, I went back to check on this. Bernard raised it in the fall. We haven't gotten any through. We haven't gotten any proposals to go forward with this. So we haven't made an effort to put in because no, we haven't seen anything. And actually, if you go to the next slide. So, I mean, our message to the group here is really, if you really want an FSC mechanism to recommend an MTI, please propose one. And I did a basic looking through. So the XOR-based one, which is RC 2733, 5109, which is ULP one, 1650 new one-dimensional redundancy, and which is basically the same as the 71, which allows holes, or saying interlead patterns for longer groups. That's those. If you have a single RTP session full bundle option, you can't use them with current specifications. You need extensions. Something that allows you to put these on SSRCs that aren't the same as the stream you're protecting. The other option is either use a separate RTP session for the FSC RTP streams. So that's something you can do with these today. I do need something around the extensions proposed in this individual draft from Jonathan Lennox, or use 2198. Which for audio I think is fine, but for video I don't. I mean, I know some people do use it. I don't think how you use it and how you get it to do efficiently is particularly clear, not for me at least. So how you actually packetize it within in that case, I don't understand how you use 2198 with video to reach any reasonable packet size.
So does Jonathan's draft just cover multi-SSRC transmission of FEC?
So what Jonathan's draft does is it allows you to, instead of having the original SSRC, saying the FEC's RTP stream currently is required to have the same as SSRC as the one we protect. When he wants to, what his scheme says, but as long as we know that this other SSRC is protecting this SSRC, you can use it. And that's what it's saying. And then using, I think it's SSRC grouping indicate the bindings. So.
Isn't this a problem for NAC too?
So wait.
Yeah, Gary, my name, Qualcomm Innovation Center. Just on when you mention other block FEC algorithms lack RTP specifications, I could say specifically for RaptorQ, we've implemented with RTP, but within the effect framework, which is general to streaming protocols. I think that's technically correct, but a little bit misleading. It does those 3 codes can work.
Yeah,
for,
they
for
can
RTP.
work, but it's just that I think from an RTP, or at least when I looked at this quickly, we don't have a full specification path for indicating, etc. We know what to do with it, but we're lacking a specification for exactly how it. I mean, it's very simple to connect the dots. It's very simple specification, but I don't think it's in place.
Well, I mean, I did submit an internet draft over a year and a half ago, even showing the SDP concept.
Yeah, sure. I mean, I know there's been individual submissions on it, and it's things there, but it isn't approved. It isn't adopted as a workgroup item. It hasn't moved forward. That's my point.
Okay, thank you.
So my feeling is that if we don't pick something here, we're not going to have FEC in 1.0. So I'm going to propose using 5109 with whatever we need to do for a multi-SSRT transmission, and make that proposal. That's what I'm shooting for at this point.
Yeah, this is something that really should get fixed. I mean, it's pretty bad. I mean, if you're just left to RTX, that won't work in all circumstances. So it's kind of sad that we're here now and we don't have anything. It's like after 3 years of work. So I think we should move forward with something. I don't know if it's like, obviously that if we're waiting for draft Linux, it might take a while, but we should definitely do something.
I think we can do something faster. I think that the whole SSRC group stuff is already needed for RTX. I think we can solve
yeah, you need a specification in some sense, and you actually need to override a must in 5109. So from a spec point of view, to get this, you need one document that updates 5109 to get this to fly.
Okay, and we don't think that this RTP usage draft could be that document?
No, because other ones it's going to be used. Sorry, I mean.
Yeah, I think for my chair hat on, I would think that needed to be done in another working group. I don't think that necessarily means that it needs to take any longer to happen than doing it in this working group. Yeah. But I agree with Justin's point that we got where we are where we are, and if we want FEC in 1.0, like now is the time to get on it, right? I do think we should ask the question though of really, we're going to go with an XOR-based FEC system in 2012? I mean, come on. There's got to be something we can do better than that.
I mean, at this point, it's like pick something that already is known to work.
Fair enough.
It's IPR free.
Plus, it sounds different. It sounds like this is old-fashioned stuff, but for the very, very small number of packets we can protect simultaneously, quite often 2, right? No more than that. It's as efficient as the others. All this Raptor stuff comes into play when you protect like 50 packets with 4 parity packets. Then is when that type of stuff starts shining. Otherwise, it doesn't matter.
So just who would be sad if we didn't end up with FEC?
Okay, so we have 3 hands. Did people hear the question? Who was going to be sad if we have no FEC specified?
Oh, okay, so just a minute. Let me try and put my chair hat on for a second. Who thinks that we should get FEC, into our, should choose some FEC scheme as mandatory to implement? If you think we should do that, put your hands up now. Okay, I'm seeing, I don't know, roughly a handful. People who don't think we should do that right now. Seeing like
4.
3. Yeah.
4, I see. There's one behind the pillar. So.
Right, and most people didn't care. So I mean,
7 and 4. 7, 4, 4 against.
I mean, you know, obviously it will take, you go to the list here, but I mean, I think that sort of brings to the point of, you know, the people who think that we should have this, let's put together a proposal of what it should be quickly, like, you know, maybe
writing.
before lunch.
Yeah.
And then let's see if we can build support for that by, you know, more than 7 people.
Yeah. Okay. So next slide. Let's move on. So circuit breakers. The draft currently mandates implementation of circuit breakers, even when proprietary congestion control are implemented and used. There's no case when you're allowed to not have it. And the intention really here is to provide a fail-safe to protect the networks against persistent congestion. That's what circuit breakers does. It doesn't do anything else. It's against persistent congestion. And it's a mechanism that allows us to publish this RTP usage and the RTCWEB media specification prior to RMCAT finishing its work. That's why it's really done. Transport people really don't like multi-megabits transmitting endpoints without any type of congestion control. Next slide. So during this last call, we got some worries about it triggering unnecessary and stop the session, which either requires the user to restart or reducing the bitrate with at least a factor of 10. I mean, circuit breakers has been evaluated. I mean, we have the results presented in Berlin, results presented in Vancouver for LTE, and the Berlin was for ADSL links. And those papers are actually in the circuit breaker draft, so you can go read them if you want to. And if you actually don't have access to IEEE, there are some of these papers are on Colin Perkins' webpage. And a very important point here is that circuit breakers work have not concluded. So it's still possible to change if you consider it to be too aggressive in causing breaks, etc., or not. I think my personal view here is this case is that the LTE evaluation showed that it's maybe too lenient in that case, and the ADSL showed it was okay, but maybe a little bit tough. So it's for my range, it seems to be working around what the reasonable point of aggressiveness. Of course, it's gonna trip in some cases where looking at the facts, maybe it shouldn't, but it doesn't seem to do this overly much. So, next slide. I don't know if I need to go through what the triggers in the circuit breakers are, but they're listed here. There's a media timeout if there's forward path is broken. There's a RTCP timeout if the reverse path is broken. There's one measuring congestion, which basically reacts like if during these intervals TCP would get less than 1/10 of what you're currently using, it triggers. And then there's soft one, which is the media usability, basically tells application, please consider what you as application do require. It triggers after 2 or 3 consecutive reporting intervals. And this probably needs to stay in this. I think what I talked with Colin has been around actually ensuring that even if you scale down the reporting interval, this timer shouldn't scale. It should actually stay in this interval, being up there around 10 seconds before you actually react, to get away from these short events that clears themselves quickly.
Just, Harald, one comment.
Yeah.
This means that circuit breakers trigger immediately if we don't use RTCP, right?
Yes.
which I just want to emphasize this because if we say yes to circuit breakers always, we also say accept that that stuff that doesn't send RTSP will not work. Period.
Yeah.
So most of the audio gateways on the internet don't send RTCP reliably. So I predict whatever you put in the spec here, what will be implemented will be ignoring circuit breakers. So I would carefully make the text such that people don't have to ignore circuit breakers to make products that work.
The text already says to ignore circuit breakers because it says that in that case, you're supposed to send low bit rate VoIP. So the RTP usage draft already says ignore the circuit breakers draft. And I like that. But the other thing about this is if you look at it, triggers after 2 to 3 reporting intervals, there's a reason why TCP has longer timeouts of 30 seconds. And that's because routing transients can operate up to 30 seconds. And so that's one of the reasons this is going to be very, very lack robustness, is it's going to trigger on like routing transients and shut down calls.
But the thing which TCP does in that case, it goes down to its basic low level, which means packets less than 1 per every second. If you have such long 30-second outages. Circuit breaker doesn't have that mechanism. It doesn't reduce the rate. It's say, okay, you have no other congestion control. It's the assumption. If you have other congestion control, you can prevent, by reducing the rate, you can end up so that it doesn't trigger. That's the point. You actually fall into this case where you already reduced the rate by more than factor 10. So if it triggers, as you just done that reduction, okay, let's ignore this. We already done something about that. Let's see what happens. It's a fail-safe. And we need a fail-safe. I don't see us going forward and getting this specification published without requiring having this fail-safe. If we want to have a certain amount of visual words, which I think we already have, fine. If you think the mechanism needs to be tuned, go tune it in ABT core.
So we've got a comment from the Java room. Randall Jessup says, a 30-second media failure will likely cause users to give up on the call anyway. Some semi-non-interactive uses may resume.
Orcus Correlate. So I don't understand, why can't the specification be approved without circuit breakers, given that we've been doing RTP over the internet for like a zillion years without circuit breakers?
Because this is the first IETF specification for actually a service, and it's a service capable of producing multi-megabits. And that's where I think the shoe squeeze you. It's saying, okay, proving something which transmits in open internet, which is obviously going to be, multi-megabits without having any requirements on congestion control.
I don't understand. We've been doing video over the internet for years with RTP with exactly these other parameters. I mean,
yes, but that's not specified by IETF.
It's not? That's news to me.
No, I think there's a very important difference between specifying a certain amount of tools to enable this and actually specifying a service, which
seems like a set of tools to me.
I'd like to ask a little bit ruder question, which is anyone planning to actually implement circuit breakers? Sort of? Like the whole thing exactly as specified?
Justin, you ready? So we're planning on implementing circuit breakers as kind of like a backstop for our existing congestion controller. If we start out at a too high rate and don't get any RTCP feedback, we'll use the circuit breakers to back down. But we have another congestion control algorithm that we hope to use an eventual standardized one coming out of RMCAT as the real thing that's going to be used for congestion control during the call.
So, I mean, I didn't get to this point. I mean, when RMCAT is done, we're going to need to update it and include it. And that's the time we can remove circuit breakers if we're happy with what RMCAT has. If it's so.
I think that no one's going to ship like a video product without some more advanced bandwidth estimation algorithm. And so whatever we say here, I'm not exactly sure what the humor is, but I mean, like, whatever we do here and like.
I guess my point is, like, I'm not against this draft, but like, and I'm more than happy to see it proceed. But like, if it's stringing the long pole in the tent, then I want it dead. So like, if we can't agree on what it's supposed to say, then I got a problem. If we know what it's supposed to say, I don't care. But, so, I don't believe for a second that we can't shit can this draft and still progress RTCWEB.
So let's get down to the actual question here. I mean, based on the raised issue, I propose we do no change to what's actually currently specified. Is people disagreeing with leaving it as required in the specification? I think that's the path of least forward of getting this draft through the ISD also, and yeah.
I've got one more comment from Randall in the Java room. He says he will certainly look at implementing circuit breakers unless we have problems in practice, but it's really a bit of a backstop to notify us of failed calls.
I think it probably should say, if you don't use anything else, you need to at least use this. But if you have something else, like, you can use that instead. Okay, then fine.
No, it doesn't.
So in my original comment, I didn't propose a change. I just wanted to know what the existing text meant.
Yeah, and I think we reworded text.
Oh, you reworded that text? Okay.
Yeah, I think so at least. Please check. Yes, we removed all this with concrete and stuff like that. So we did touch the text. But yeah, I took this based on the discussion also with Emil. So that's why I brought it here. But summarize for a note taker. I mean, I get the impression that I tried to ask the question. I didn't get a lot of pushback on leaving it as it is. So that's. I'm going to go with that unless people scream now. So saying that that's the conclusions. Yeah. Next slide. What?
Okay, never mind.
Nobody screamed. So let's move on to the next issue. So mandating signaling. Colin raised that he really liked to require signaling before you use an extension. So I want to first say, okay, there is some extension that you actually must have negotiated and agreed on that both endpoints are willing to use and going to use it before you use it. Otherwise, things really fail. Then there are some extensions which really just provides a set of functionality, which if the other endpoint doesn't do, I mean, just ignore them. It's at least no big interoperability failure. You just lose the functionality. And in those cases are where we have written is that you should signal in those cases. This is really not intended to be saying that you really should skip signaling. We really encourage signaling. We do want people to see using signaling, but we do have some reasons for saying that cases when unsignaled extensions might show up. So these are legacy, this kind of interoperability cases, guided gateways that wouldn't remove an option which isn't signaled agreed by the signaling gateway, but not the media gateway. So we also have Postel's law, be conservative in what you send and be liberal in what you accept. So, and really robust endpoints do need to be able to ignore things it doesn't understand. So That's the message in this case. Krister, there's one there and one there.
Yes, Chris. I mean, in general, for example, if you're using SDP or SIP, I agree with this, but I mean, doesn't this really depend on what signaling protocol you have on the wire? For example, if you're using protocol X, which maybe by default requires you to do something already, then you don't need to signaling it because the protocol already requires you to use it. I think it should be more about the fact that if you're using a specific protocol and there are mechanisms for signaling usage or something, you must do that. I mean, we shouldn't say that something is implicit, but the actual signaling protocol that you do use may do that. So I don't really.
But yeah, but that's I agree with you. But that's signaling itself, because then the protocol have made either implicit or explicit indication saying that by using this, you actually you need to have the following configuration for the following parameters. That's signaling in my view from the RTP stack point of view. It's saying, okay, somebody's told you how things comes into this. So, I mean,
just to clarify, but now when we talk about signaling, we mean what goes on the wire. This is not an API or anything.
From this draft point of view, in some sense, signaling or API is the same. It's you've been configured to do the following, and it's after either explicit configuration or negotiation or something. It's.
I mean, in JSEP, for example, where you do use SDP, this is of course true. I mean, if you want to use RTPC multiplexing, you must signal it multiplexing. And my issue was that what goes out on the wire, maybe H666 whatever. So it's like maybe that protocol already says H666 endpoints always use RTP RTCP multiplexing. So you're not gonna signaling it on the wire.
Yeah, okay, but that's I don't think I see a contradiction in this case. So
yeah. Martin Thompson, I'm with Magnus. I think the idea that signaling protocol has implicit behaviors is still signaling. My objection to this is to the application of Postel's law, which I think is a terrible thing in general.
Sorry, I didn't.
Postel's law. You have the appeal to authority in there, and I think it's actually just wrong. We want predictable behavior out of endpoints, and that predictable behavior is if it's signaled, you do it. If it's not signaled, you don't do it. Very straightforward. The only reason that we have some of these things in the document that say you must ignore extensions, blah, 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 is to deal with the fact that, yes, we know there are some people out there who are not following our rules, but our rules should be that you don't use something that you're not told to use.
Yeah.
I think that's far easier to manage.
Okay. Yeah, I don't think I disagree with you within that. Give it the mic to Colin. So let's see.
So I'm really agreeing with Martin here. I mean, my concern on this, the use case that I was worried about is you have a legacy device that can't deal with the extensions, and in fact doesn't, it doesn't silently ignore them, but actually fails. And I wanted to make sure that we had, I don't care what the browser does by default, but I wanted to make sure that you could tell the browser, and maybe I misused the word signaling, but through its control surface, whatever that should be, you can tell it to not do this or to do it, and it would do what you told it to do, instead of doing some other random thing, because we just need a control surface. That's it.
I think I'm fine with that, but can you propose some wording? See what you want to change and how it looks. That would be appreciated. So, next. So yes, PLI. This is from Suhash. I didn't quite get it, and I don't think he has followed up. So, it's rather unclear what's proposed. I mean, here's the question: should we add the requirement for the WebRTC endpoint sending PLI message? I assume that's actually meant saying that the receiver detecting loss must send a PLI message when it's got a picture loss. But what we currently have is that WebRTC senders must understand and react to PLI feedback messages as a loss tolerance mechanism, and receivers may send PLI messages. I propose that we leave it as it is, but I'm willing to hear input. So.
Cullen here, I think what Suhas meant, which maybe is out of scope of this discussion a little bit, is should there be a control surface at the JavaScript layer to tell the browser to send a PLI message for a given media stream track?
Okay, that's not, yeah. It's not
I think that, I'm pretty sure that's what he meant. I don't see him here. Otherwise, I wouldn't have stood up.
Yeah. Okay, but in that case, it's WRTC question, not really an IETF question. It's not this draft. So let's leave it as this and move on. If no one else has input into this, you're okay, Justin, with after actually reading the text for fear and PLI? Okay, he's not satisfied. Next slide. So I'm going to be quick about this. This is just a clarification on why this draft recommends a 4-second TR for having the SAVPF interact, minimize the issues with interacting with AVP or SAVP. Interacting with AVP, of course, requires you have to have a gateway that strips away the security layer, but still, if you have the rest of the RTP go through such a gateway, and you interact with an AVP. So this graph, at the bottom, this is the different TRR int values for an AVP SAVPF endpoint. What values use figure to, and these curves represents how many intervals, reporting intervals, the other sees. So over here at 2 seconds, the AVPF will see, no, the AVP receiver will see almost 8 AVPF report intervals. However, the AVPF endpoint will only see 2 reports before it times out. And that's why 4 is recommended here as being the bottom where these reasonable values. So that's the clarification of that. I think we're done. Let's take it to the next slide.
So Martin Thompson, Magnus, is it usual to provide clarification in this form, or actually include something in the document?
Yeah, I wish we had a reference for this because
this was as clear as mud to me, but obviously I can't see any of it. So
yeah, the problem really is we have. I mean, this is to some degree a bug in AVPF. That's the fundamental to why this behavior, and it's not 5, and that's why it's 4 is better. The longer slides that I actually sent out actually try to make the whole case for why it ends up in this situation. And we don't have it written up in a draft form. So sorry. Yeah.
Sounds like an action item to me.
Yeah, well. Yeah, let's see what we can do about it. But I wanted at least to answer the question, and I think the graphs, it needs the graph support to actually show where it's coming in. And so I think we're done with this topic, aren't we? I think this was the last slide.
Are there any other questions, either locally or from the remote participants? Okay, I propose we take a short break since the coffee is now here, fuel up, and then we'll return. By short, what do I mean 20 minutes? So In what time zone would you like me to? 9:50 local time.